So what we're going to look at today is finding least common multiple. Now, the way you start least common multiples should be very similar to the way we found what last Friday or Thursday. Step 1 is exactly the same as what we figured out on Thursday. What was that? James? Greatest common factor. Same exact step 1. Make a factor tree and write the prime factorization for each number. We did that on Wednesday. That's what we learned, factor trees and prime factorizations. Then on Thursday, that was step 1 to finding greatest common factor. So now we're using it again to find least common multiple. So step 1 is not new at all. This is our third day doing it. Make a factor tree and write the prime factorization for each number. First thing you're going to do. Now, like I told you on Friday or Thursday, I keep forgetting we didn't have school. Like I told you on Thursday, you will eventually just learn the prime factorization for a lot of smaller numbers. Okay? And if you know it, obviously you don't have to make a factor tree to figure it out. All right? But until you start like memorizing some of those prime factorizations for numbers, you'll have to do a factor tree to figure it out. All right? But hopefully you realized last week on Wednesday and Thursday that it doesn't take that long to make a factor tree. And it's actually an easier way of doing it. So then, once you have your prime factorization written for both numbers, or if it happened to be 3 numbers, step 2 is the tricky one to explain in words, but it's not that hard to do. So once we do examples, it'll make more sense. You are going to end up multiplying the prime numbers that show up in both of the lists based on which list has the number the most. Okay, and again, I know that sounds kind of confusing. It's not as confusing to do as it is to explain in words. Okay, so again, for those of you still writing it down, you're going to multiply the prime numbers that show up in both lists based on which list has the number the most. Okay, so step 1 is the same. This is day 3 doing step 1. Step 2 is what changes depending on if you're doing greatest common factor or least common multiple. Okay, so we're going to look at some examples of this. All right, first we're going to look at finding the least common multiple of 6 and 8. So the first thing you would need to do if you don't automatically know the prime factorization for 6 and the prime factorization of 8 would be to make the factor trees. These are 2 numbers you'll find out you're doing prime factorization for a lot that you eventually won't have to make a factor tree for them. You will just know this times this or this times this times this is the prime factorization. So it is not always necessary to make a factor tree. You will just learn some of them. So what are we going to multiply to get 6? There's only one option for this. Jordan? 2 and 3. And those are both prime. So our prime factorization for 6 would be 2 times 3. Most of you probably didn't need to make a tree for it. And 8. What can we multiply to get 8? There's only one way to start this one. John? 2 and 4. 2 is prime, but 4 is not. Okay, so then what are we going to multiply to get 4? Mateo? 2 and 2. And those are both prime. So our prime factorization for 8 is 2 times 2 times 2. You will use that a lot, and you'll eventually just memorize it. Okay, that is what we did Wednesday and Thursday of last week, right there. Absolutely nothing new. Then, what changes slightly today is what we actually have to use to find the LCM. Okay, again, LCM is what you will have to find to get common denominators when adding and subtracting. So at least common multiple, basically what you're doing is you're figuring out 6 and 8. What is the smallest number both of them will go into. That's what you're actually figuring out, okay? And you can't always just multiply the two, all right? You'll see that doesn't work for this one even. So here is the quickest way to find LCM. All right, after we do 3 examples, I will show you kind of the method that was taught in 4th and 5th grade, which still works, but sometimes takes longer. All right, so to kind of explain what this whole step 2 was, if you look at this list of prime numbers, we have 2's and we have 3's. So in finding LCM, you're going to have to use 2 and 3. Which list has the most 2's? Mateo? And how many 2's does it have? So to find our LCM, we're going to have to multiply 3 2's. Which list has the most 3's? It's not a trick question, so don't think too much. Which list has the most 3's? Jordan? And how many does it have? There's only one, so you're only multiplying 1 3. This is where you could use a calculator to actually multiply this out if you need to. A lot of them are small enough you can just go through it in your head, but some of them may get bigger that you'll want to pop up your calculator and actually multiply these out. This one we should be okay. So we're just multiplying these all the way across. 2 times 2 gives us 4. 4 times 2 gives us 8, and then 8 times 3 gives us 24. So our least common multiple for 8 and 6 is 24, not 48. The smallest number that 6 and 8 will go into is 24. That is your least common multiple. Okay, we're going to do another one before I ask if we have questions. So now if we need to find the least common multiple for 12 and 16. Okay, nothing new yet. So just like we did on Wednesday and Thursday last week, you're going to make a factor tree for 12, a factor tree for 16. So take 30 to 45 seconds to do that. That's nothing new. Factor tree for 12, factor tree for 16. Now, both of these can start different ways. So your neighbor may start it a different way than you, but when you're done, the prime factorization is always the same. So someone tell me how you did 12. What can we multiply to get 12? Leah? 4 and 3. You could have done 2 and 6. It will still end up the same. 3 is prime. 4 is not. So Leah, what for 3? Or 4, I'm sorry. 2 and 2. Those are both primes. So the prime factorization for 12 is 2 times 2 times 3. Even if you started it with 6 times 2, you would still end up with 2 times 2 times 3. 16. Again, there's 2 different ways to start this. Jordan? 4 and 4. You could have done 2 and 8. Okay? And the 4s, what do we need to split those into, Jordan? Yep, and both of them are the same. So they're both 2 and 2. So the prime factorization for 16 is 2 times 2 times 2 times 2. That's what we did Wednesday and Thursday. Then what is new today is finding LCM. So again, if you look at your list of numbers here, we have 2's and we have 3's. You have to use them. Which row has the most 2's and how many does it have? John? And how many does it have? So we have to use all 4 of them. And which row has the most 3's? Again, it's not a trick question. John? And how many does it have? Just one, so you have to use it. Okay? Then to find the LCM, you're just multiplying all of these numbers. So 2 times 2 gives us, 4 times 2 gives us, 8 times 2 gives us, and then this is where I would probably either pop out a calculator or write it down. We need to take 16 times 3. None of us were taught to memorize that in elementary school, but we have a way to get the answer. Okay, so it'd give us 18. So 48 is the least common multiple for 12 and 16. Now questions. Don't worry, we're going to do one more together. But any questions about where I'm pulling these numbers from? Factor tree to make prime factorization, and then I'm multiplying all of the prime numbers based on whichever row has the most. Okay, then the next one we're going to look at is 12 and 15. Now, should you have to make a factor tree for 12? Why, Mateo? You just did it on number 2. This is why writing stuff down is so important. Even when you're doing your IXL, I would probably write my prime factorization on paper because you'll probably get the same number more than once. Then you don't have to think about what it was. There is no reason to make a factor tree for 12. You already have the prime factorization. And you probably don't need to make one for 15. Okay? You just need to come up with a prime factorization for both of them. So 12, like Mateo said, is given. We should be able to just copy that from above. 2 times 2 times 3. What would 15 be? Even if you didn't make a factor tree. You can make a factor tree if you like to see the visual that it's all finished. Jordan? 3 times 5. Or 5 times 3. But prime factorization, we generally write least to greatest. So then to find LCM, we have 2s, 3s, and 5s. You have to use all 3 of those numbers. Which row has the most 2s and how many does it have? John? And how many does it have? So we have to use both of them. Not a trick question. Which row has the most 5s and how many does it have? Jordan? And it's got how many? Just one. And which row has the most 3s and how many does it have? John? They both have the same, so we're only going to use one because they both only have one. Okay? Then again, I would probably pull out a calculator to do my 2 times 2 times 5 times 3. Okay? Or I look at this as 15 and this is 4. Okay? Or 15 times 2 is 30. 30 times 2 is 60. Several ways to look at that because order does not matter when we're multiplying. 2 times 2 is 4. 4 times 5 is 20. 20 times 3 is 60. However you need to look at it, or pop up a calculator, 2 times 2 times 5 times 3. You still get 60. And I didn't have to make factor trees for that one. Okay? Now, you don't have to write this down unless this seems easier for you, typically the way they teach it in 4th and 5th grade. So, typically what they would teach you, because you wouldn't have done prime factorization and factor trees yet, is to list your multiples of the 2 numbers. Here's why I don't like that. To me, it makes me think too much because then I have to think of, okay, what's 12 times 1? What's 12 times 2? What's 12 times 3? Or I have to keep adding 12 in my head. I'm more likely to make mistakes when I do that than when I try to split numbers down. Okay? Either method works if you do it right. So you have to figure out which is easiest for you and just perfect it. I'm going to be honest with you. This is honestly easier. Maybe not today because it's new. But if you could get used to doing it this way, it will be easier. Okay? So what you would have to do with this, now I wouldn't already know it's 60. For me right now, it's going to make it easier because I know what the LCM is. But you would have to list the multiples of 12. So you keep adding 12. And I messed up earlier today. Okay? Because like, one, I'm talking and I don't always think when I'm talking, but you have to keep adding 12. And what I'm doing in my head is I'm adding 2 and then adding the 10. That's kind of how I break it apart. And on this, I usually add 10 and then add the 5. So then my smallest number that's in both lists is 60. But you might have to like continue this on not knowing where you need to stop. Because you have to keep the list going until you get something common in both lists. Sometimes those lists can go on forever. Sometimes you will think, well, there's nothing in common. Probably because you added wrong. Okay? So I promise this is quicker and easier, but if this makes more sense to you, you can use either method. Because like I said, as long as they're done right, they both work. Okay? Nice thing about this is if they ever asked you for 6 and 8, find the GCF and the LCM. You can do it from one prime factorization list. Okay? Because step 1 is the same for both. Then what you do to find LCM and then GCF is slightly different. I mean, I could easily tell you the GCF of 6 and 8 is 2. The GCF of 12 and 16 is 4. The GCF of 12 and 15 is actually it's 3. Okay, I don't expect you to be that fast, but you will be that fast if you keep using the same method. All right, any questions? Either way works. All right, so your assignment today. First of all, someone tell me what you need to bring Wednesday, Thursday, and Friday that you have not brought for a while based on our agenda. Mason? Math book, so you better find it within the next 22 hours. Okay? For today, you're doing IXL E10. Here's what you need to realize. This is your first assignment of this grading period. Right now, everyone has 100%. If you don't even start this, you will have a 0% this evening. This is your first assignment. What you get on it is your grade until I get other grades put in. Same way I'm scoring them. You get to an 80, it's a 9 out of 10. You would have an A. You get to 90, it's a 10 out of 10. You'd have 100%, an A+. Get to 100, you would have 12 out of 10, which is 120%. Most kids between the first 2 class periods got to anywhere from 80 to 100 in 15 minutes or less. There is no reason to walk out of here and this not be done at school. The other thing that's a grade every week is your warm-ups, and I have some kids that continually don't do them. IXL E10 is your first grade of the grading period. Get it done now before you walk out of here. If you finish that, you could go ahead and start looking at our rate and ratios IXLs. R1 and R2 are not that difficult. But if you get to like R3 and R7 and they start getting confusing, wait till we talk about it tomorrow. But R1 and R2, you could probably get started on when you finish E10. But E10 must be done first. Any questions? And then if your warm-up was not submitted, please get that finished.